K-means is a way of grouping data through an iterative process by adjusting randomly initialized cluster centers. Let's assume we have a dataset with two blobs that we want to group. We will randomly initialize two cluster centers x1 and x2, and then for each point find which of these two is closer. The cluster center closer to the point wins that point. We do this over and over for each point in our dataset until each point in our dataset is assigned to one of these clusters. The point closer to 2 will be assigned 2, and all the other points would be assigned similarly. And finally, when all the points are assigned, it's time to update the cluster centers. The new x1 will be the centroid or mean of all the points assigned to it, thus the term k-means. And similarly, x2 will be the mean of all the points assigned to x2. And so we adjust the clusters and repeat. As we can see in this animation of k-means, by repeating the process of adjusting cluster centers, they slowly coincide with their respective groups. To implement k-means in Python, simply import random and numpy library and create a k-means class with k and maxiter as input, with k being the number of clusters you want and maxiter being the number of times you want to adjust the clusters. And to compute distance between any 2 points, we will use Euclidean distance. Then we can initialize our cluster centers randomly. We will use the random library to sample k random points from the input list. Now we can declare our fit method, which will be our main method, and call our initialize method inside it. Now we set up a loop which runs max iter times. Inside this loop, we need labels variable to track the label of each point and clusters variable to keep a track of which point is assigned to which cluster center. Now let's loop over all the points in our dataset and find the cluster center closest to it. Label of the current point will be the cluster center closest to it, and that cluster center will also get that point. Now we can update our clusters by looping over the clusters variable. If a cluster has some points assigned to it, the new centroid of that cluster is the mean of all the points assigned to it. We can now use our kmeans class, so let's generate some data randomly using sklearn and plot it out. Our data set has 4 distinct clusters. Let's see if kmeans is able to group them together. To cluster, simply instantiate the kmeans class with k as 4 and maxiter as 5 and call the fit method with input data x. After it finishes, let's visualize the results again and this time color our graph based on kmeans labels. As we can see, kmeans was able to group this data together really well. But wait, one can easily screw up k-means if the input data is not scaled properly. For example, if one dimension of the dataset is 10 times of the other, so one dimension is between -100 and 100 and the other one between -10 and 10, you start to get very weird k-means clustering results. So make sure that you always scale your data. Standard scaler is a good practice, and remove any outliers from it before applying k-means to get good results. Another sure shot way of screwing up k-means is to use an incorrect k value. So try k-means with different k values and pick the best result. This has been k-means in 5 minutes.